you're looking at a triangle. And now we're going to label each vertex of the triangle with capital letters. And we're going to call this triangle LSC. And now you're looking at a second triangle on the right. It's blue, but it is the same size and shape as the black triangle. The blue triangle and the black triangles are congruent triangles. Because they're congruent, there's a relationship, and we label the blue triangle one vertex as L with an accent mark, another with S with an accent mark, and another with C with an accent mark, but we call that L prime, S prime, and C prime. We use the same letters, but the accent mark means that they are still two different points, but the original letters are the same because there's a relationship. We say that the vertex at L in the black triangle corresponds with the vertex at L prime in the blue triangle, the same with S and S prime, and the same with C and C prime. We label the blue triangle L prime, S prime, C prime. And then the symbol that I've just added on the bottom is the symbol for congruence. So the sentence at the bottom is read, triangle LSC is congruent to triangle L prime, S prime, C prime. And now we've thrown a red line in between the two triangles. That line's there for a reason, because the blue triangle is said to be the reflection of the black triangle across the red line. The red line is the line of reflection. If we connect corresponding points as shown, we get segments that are perpendicular to the red line. I think you can see that the green dotted lines all make right angles with the red line of reflection. There's points along each side of the black triangle that all correspond with points along each side of the blue triangle, but I've selected the three vertices. And the segment from L to L prime is perpendicular to the red line. So is the one from C to C prime, and so is the one from S to S prime. And you may have noticed another relationship, and if you did, you're correct. If we label the points of intersection of the green dotted lines with the red line, and we're going to label those A, B, and D because we've already used up the letter C, we now realize that the distance from L to A is the same distance as from L prime to A. What we have written is the length of segment LA is equal to the length of segment L prime A. And that is also true about segment CB and segment C prime B, and of course it's also true about segment SD and segment S prime D. Here's another triangle. Here's a given line of reflection. And what we're going to do now is show how to reflect a triangle over a line. Get out your trusty ruler and line up the ruler so that it's perpendicular to the line of reflection. I've done my best. This is not a perfect drawing, it's a sketch, but I'm hoping when I'm done, the new triangle will look like a reflection of the original black triangle. I'm using the vertex that's up at the top of our screen, and I've used the ruler to measure in inches, and I've tried to measure so that the blue dot that I've just added is the same distance from the red line as the vertex of the black triangle that I have the ruler next to. And now I'm going to slide my ruler down and work with the vertex which is the closest to the line of reflection. And looking at my ruler, I make the blue dot as shown, trying to get the distance of the blue dot the same from the red line as the vertex that it corresponds with. And there's one more, and it's going to really exhaust the length of this ruler, but I do my best, and there's my estimate. I tried to make the distances the same, and the ruler was used to its capacity. Now I connect my three blue dots, which technically are points, and specifically these points are vertices of the blue triangle. And there's my reflection. And here's the same triangle that we just used. It's been rotated a bit, and our line of reflection passes right through the middle of the triangle. So the part of the triangle on the left side of the line of reflection will reflect to the right side, and the part of the triangle on the right side will reflect to the left side. but we still do one vertex at a time. So there's my ruler. I've chosen a vertex, done some measuring, made a dot. Moved the ruler down to the vertex closest to the line of reflection, measured, made a dot, and here's the one that's the farthest away from the line of reflection. My ruler is not large enough, so I'm going to have to be careful. Take a measurement. It looks like it's running from the 8 to the 0. I'm using centimeters. That's 8 centimeters. I have to very carefully slide the ruler, keeping it perpendicular, measure out 8 more centimeters, and there it is. And now I'm going to connect these 3 blue dots. And when I have finished that, I'm hoping that the blue triangle will look like the reflection of the black triangle over the red line of reflection. And now let's reflect a word. I chose the word math, and I reflect it over the red line, and over on the right side it says math. But then I remembered that often when you hold up a book to a mirror, letters appear to be backwards, and it dawned on me that by coincidence I ended up with 4 letters that when they reflect, they look the same. So I picked another word, geometry, and let's reflect that. And you'll see that the G, the E, the second E, and the R all look different when reflected over the line of reflection. But the letters O, M, T, and Y all look the same. And now we'll take a word ambulance written out horizontally, and we're going to reflect that over the red line. There's the word ambulance. You see the letter A, which starts the word, which is the farthest away from the line of reflection on the left side, must be reflected so that it's the farthest away from the line of reflection on the right side. You'll also notice that the letters that are reflected on the right side are hard to read. And if you've ever looked at the front of an ambulance, that's often the way the word appears on the front of an ambulance. And that's so when an ambulance on an emergency call comes up behind other vehicles, the drivers of the other vehicles can look in their rearview mirrors, and then they will see the word ambulance the way it's supposed to look, and they'll know to get out of the way and let the ambulance pass. Well, reflections are often easy to do on coordinate graphing planes. So here we have a parallelogram graphed in quadrant 1. And the new red parallelogram is the reflection of the black parallelogram over the y-axis. And because of the grid, it's easy to use the grid to count to get a good quality sketch of the reflection. And the way it's done is one vertex at a time. I started with the vertex closest to the y-axis, and my red vertex is the same distance on the other side of the y-axis. Then I did the one at the top, and I believe that was 6 units to the right, so the red one is 6 units to the left along the same horizontal grid line, and now I can connect the first 2 vertices. Then there's the next one. That's 9 units to the right, so the red one is 9 units to the left, but still on the same horizontal grid line. And the final one, 4 units to the right for the original, 4 units to the left for the reflection. I now can connect all 4, and I've finished my reflection of the black parallelogram over the y-axis. And now this next example, the blue parallelogram is the reflection of the black parallelogram over the x-axis. And the beauty of all this is our new one, the green one, is the reflection of the red one over the x-axis and the reflection of the blue one over the y-axis. And now we're back to our original triangle, and we've put it in an application called the Geometer Sketchpad. The red segment has been designated as the line of reflection, and the blue triangle is the reflected triangle over the line of reflection. And because it's in this application, and we've designated certain things as shown, if we change the black triangle, the reflection changes with it. So I'm going to do a few examples. And also, if we change the line of reflection, it affects the reflection. And in fact, here is an example of the line of reflection through the original figure so that the right side reflects on the left side and vice versa. Figures that have the same size and shape are congruent. A reflected image of a figure over a line is congruent to the original figure. The line of reflection is the perpendicular bisector of all segments connecting corresponding points of the two figures.